Okay, so let's start. Okay. Hello everyone, welcome to this session on Python for AI. In this session, we are going to have an introduction to AI. We are going to study some basic AI algorithms. We are also going to implement one such basic AI algorithm in Python. And along the way, we are also going to discuss some of the basics of Python that will be required to implement that technique. So let's start. I'll just start with the introduction first. I know I'm seeing a lot of people that I know over here, but I'll just give an introduction to just everyone so knows about that. So who am I? I am Sakshay. I am a final year undergraduate student at IIT Ropar studying computer science and engineering. Now, apart from my studies, I also have a YouTube channel that goes by the name Robotics with Sakshay, where I post different videos related to AI and robotics. Now, I have also done different projects. One of my recent project that I did was developing a software to test different motion planning algorithms, and that complete software was developed in Python. And it, as we know, motion planning algorithms involve AI. So I have done some work on that. And why am I taking this session and why I have the YouTube channel is to explore this field of AI and robotics, to learn more about it and help others to learn as well. Okay, so let's start. Okay, anyone knows about this YouTube channel that I have pasted the photos of in the slides? You may recognize, if you know, you may recognize it from the thumbnail as such. Any guesses? Okay, so this YouTube channel is okay. So this YouTube channel is the that goes by the name Code Bullet. So this on this channel you may find various different videos that are related to AI, how AI is applied, and so on. The presenter of this channel, I don't know his real name. The presenter actually implements different AI techniques that are in a simulation based environment for, like, let's say games, and he presents them in a more fun and storytelling type of way, so that it is also interesting to watch. You can check out, yes, Code Bullet. So you can check out the channel if you would like to see more applications of AI. Now on the left side over here in the middle, we can see that there are AI learns to series. So in particularly these videos, he codes algorithms that learn to do something like teaching the AI to fly, teaching the AI to walk, and teaching the AI to drive. On the right, we can see that we have the created series. In this, he just makes videos that are related to creating an AI. There is no learning involved, but there is some form of intelligence that is coded in the channel, in the code. So what AI actually is, AI stands for artificial intelligence, and it's just a way, we can say, to mimic the intelligence that is shown by us humans. Now, why we would like to do that is to just automate the tasks that we have. Like, we can also see over here that if we want to automate the flight of an airplane, that then we can use an AI that would fly. We have self-driving cars that enable AI to actually drive on the roads, and so on. So that is it is. Now the part of the human body that actually does all the intelligence based tasks is pretty obviously the brain. It has a lot of different tasks that it does, like controlling the body functions, helping us hear, process the information, helping us walk. All the things that we do is just related to the brain. AI is involved in mimicking these processes in some way or another. Now, if we consider the different components of AI, then we have natural language processing, that is for speech based intelligence. We have computer vision, that is for vision based intelligence. And then we have machine learning, that is for learning based intelligence. So all these are basically trying to mimic the different functions that our brain performs under the umbrella of different components that we have that all constitute this AI. And not only the human functions, but AI in some way also tries to mimic the tasks that are done by nature as such, that we can see in nature, like the intelligence, that the swarm intelligence or the collective intelligence that is done by the ants, as we can see. It also tries to mimic the intelligence that we have in plants. Like in plants, the thing is wherever the sunlight is, the plants try to grow towards that. So that is also a kind of intelligence that is shown, and AI is trying to replicate that intelligence. So this is also a case. And Soros is also here. He is actually the founder of the Lighthall community, and he has also joined. So yeah. Okay, going on to the next one. So solving a Sudoku would also involve intelligence. Solving the Sudoku would also involve intelligence. Now let's consider some example from the Sudoku grid that we have given over here. I think all of the people who are here would be familiar with Sudoku. It's just a mind game that we have over here. We have to fill the numbers 1 through 9 in each of the empty spaces that we see over here. And the condition is that in each column that number should not be repeated, and in each row that number should not be repeated. There is also another constraint that we can say that in these sub squares that we see over here, the number should not be repeated over here as well. So let this sixth column. Let's consider let's consider this fourth column over here, and let's say that we want to fill the number 8. So how many choices do we have over here? There's one empty cell over here, one over here, and 2 over in the bottom here. So we have 4 options that we can fill the number 8. But now let's check this in detail. In the first row, we cannot fill 8 because it is already being occupied by the first row. We cannot fill 8 over here as well, since we already have an over here. We cannot fill it in the second last row as well, that 8 is over here. So the only choice that we have is to fill an 8 in the last row. Now to represent this mathematically, we have this what is called a state graph, as we can see in the top right. We are currently at the fourth column. We want to solve the fourth column, and we are at that state, and we have possible actions that will lead us to further states. These possible actions are 4 over here: the first row, second row, 8th row, and 9th row. Now from these 4 actions, we can only take a single action, as we just checked for that. We can only go to, and after we have filled the number 8 over here, then we move from this fourth column, the red colored state. We expand the graph further, and we would see that we now have different actions that we would like to take so that we can proceed so on. Let's consider another example. Like in the first row, let's say we want to fill the number 3. Now we can fill 3 over here, as no 3s that we have already filled. We cannot fill a 3 over here, and we cannot fill a 3 over here, but we have 2 places where we can fill the 3, the third row, the 6th row. Now over here, the condition, the difference is that we have 2 places where we can fill 3. So how would we go about doing this is, if we consider a very basic kind of approach, that we would first fill the 3 in the third row over here, and then check if the Sudoku is solved or not. If the Sudoku is solved at the end, then we are satisfied that 3 was going to be placed in the third row. But however, if the Sudoku is not solved, then we will go back. We will change the position of 3 that we had, and then again move on to solve and see if the Sudoku is solved. Now, based on what we have over here, Sudoku is going to be solved in these 2. There is no other way that it is not going to be solved. Now, this technique that we are applying, that we are searching for a correct answer, is called searching. Now, in AI terms, this is also called searching. Searching is a kind group of algorithms where we try to search for a correct answer or solution to a given problem. Like over here, we can see the problem was, if in very basic terms, okay, so the complete problem is to solve the Sudoku. But a simpler problem over here we can see is that we need to fill the number, let's say 3, or we need to fill the number 8. So these are the small problems that we are searching for in this state graph. Searching is the foundation of, we can say, AI. Almost all the different things that we can see in AI, they mostly involve searching or finding for the correct answer. So that's what searching is. So any questions regarding that? If you're clear with that, any questions if you have for that? Okay, now I have a quiz over here. Now let's say that we fill the number 8 in the fourth column over here. In the fourth column, we fill the number 8, and now we have to fill the number 1. So the quiz is, I'll just launch the quiz from over here. The quiz is, how many available actions do we have if we want to fill the number 1 just after we have filled the number 8? So a quiz would be available over here. So you can answer in that quiz. Okay, so not everyone had answered the quiz, but no problem. But I can see that. Okay, so some of the people have. So the options for the quiz were 1, 2, or 3. Now I mean the answer actually depends, but I would say that the possible actions that are there are 3. There are 3 possible actions that we can take after we have filled the number 8. Once we fill the number 8, the last row will be occupied. And now to fill the number 1, we have 3 choices. And from these 3 choices, only one action is that we are going to take. So the answer would, you can say it can also be 3 or it can also be 1 based on the specific of the questions that we have. Okay. So let's move to the next one. Now, let's consider a more practical example. In the case of a self-driving car, as we can see over here, searching is involved. Now, based on some mathematical function or mathematical algorithm, we can generate the different trajectories that we can see in these white colored thread-like things over here. So possible different trajectories that a robot car can take while it is moving on the road. Based on the search, like how extensive the search can be, like it is going to search for those paths that will help it avoid the obstacles and also help it quickly move through the traffic. So the green one over here is the one that is the searched one, which it feels that is the best to take. So over here we can see that still searching is involved, the same or similar kind of search that was involved in the Sudoku solver that we saw before. So in a way, we can say that the algorithms are quite similar, but just a level of more detail and complexity is involved. Only simple search is going on. I would say that even when we ourselves drive cars, something like this is also going on in our brain, like we try to find different paths through the traffic and so on. So yeah. Okay, now let's get to a very basic search algorithm that is also called binary search. Maybe some people may know about it over here, but we'll just discuss it. And so we will discuss it in the form of a game. Let's say we have a game called Guess the Number, and I am the host, and you are required to guess the number that I have thought in my mind. Now, a very basic rule of this is that the range of the number that we can select is from 1 till 100. Both the 1 and 100 are included. And you will tell me a number, and I will you will tell me a number, and I will say if that number is the one that I have guessed or not. If you have guessed the correct number, then the game is done and you win. That's the whole game. Now, if we think about it, then there can be mainly two methods that we can do this, that we can solve this game that we have over here. Either we can randomly just choose numbers from 1 to 100 we just by saying it, and then I'll say that it is correct or not. And in this way, after some point of time, the number would definitely be guessed because there are limited number of numbers over here. Next way can be that we count the sequence, like one by one. First we check 1, is it the number to be guessed or not? Then we check 2, 3, 4, and so on. Another method that I have not listed over here can be that we go from a both way search. Like first we say the number 1, then 100, then 2, 99, and this way we exhaust the search that we have. Now, if we talk about it in a more mathematical way, then we can say that the average number of turns in the random picking algorithm would be 100. The mathematics that I did to solve this was just 1 divided by the probability that the number is. So it's just a rough estimate over here. And the rough estimate for counting sequence, the average number of turns would be 50. Now, these two algorithms that we have thought of are also AI, because it is also solving a problem using some form of intelligence. Although the intelligence that we have over here is quite basic and it is just doing just simple checking, but it's also an AI. Now, but let's say that the average number of turns that we have, that the process that we are working on is quite expensive, and that we cannot consider these many number of turns till we guess the right number. Let's understand it through an example. Now I've put a screenshot of a game over here. Can anyone guess which game is this? This is a pretty, I think, old game, old computer game that we had. Yes, so Manav guessed it. It is Pocket Tanks. Now the objective of this game was that it is a two-player game. The two players are placed in these tanks over here, and the objective is to shoot each other's tanks by firing different missiles. So how this game is played is that we have to select the power of the shot, how much hard we want to hit the missile, and we have to set the angle of the shot. So based on that, each of the players fire, and if the missile misses, then the chance is lost, and if the missile hits, then a score is given to each of the player. On the right, it's a more easier or more basic version of this same Pocket Tanks game. This is also, I have made another video on this. You can check this later if you want. Now, in this basic version, the thing is that we have already set the power of the shot, and the only thing that we need to do is select an angle. Now let's consider the search algorithms over here. Now, the previous two algorithms, the counting sequence and the random picking. Now applying these two algorithms over here is a little bit, let's say, difficult. Why? Because the range is going to be a real number, and it's going to be any number between the range that we have over here. So just randomly throwing and checking is going to take a lot of time, and even simply just iterating by counting again and again is also going to take a lot of time, because the number list is going to be huge, and if we even increment the angles one by one, and by that time if the other player hits us, then it's a loss kind of game. So in these kind of situations, the AI needs to perform a bit faster than what we have discussed in our previous approaches. And for that, we are going to have use the binary search technique, which is coming up in this slide. Now, let's say that another constraint that we add to the game is that, let's say when you tell me the number that you want, let's say that I know the guess number and you tell me the number that you have in your mind. What I can do is tell whether the number that you have told me, is it less than or greater than the guessed number. Now let's say that the number that you have to guess is 50, and you say that 25 the number or not. I will just tell you that the number that you have to guess is greater than 25. And otherwise, if you ask me is 75 is the number, then I can tell you that 75 is greater than the number to be guessed. Now, this information that we got from me is actually really important for the binary search technique to do its task. Even in the Pocket Tanks game, this can be explicitly found out after we see the shots that are fired. If a shot is fired and it lands somewhere before the other tank, then the number to guess is less. And if the shot that is fired falls just after the tank, somewhere after the tank, then the number to guess is greater than what we have. So something similar is going on in the Pocket Tanks as well. Now, binary search is just a strategic way to find the number that we have. Let's say that the number to guess is 23, and we know that the range is 1 till 100. So what we do is we take the middle value of this range. It's going to be 50, and we ask if 50 is that number. Now the information that we get is 50 is greater than the number to guess. Now this information tells us that our range is now reduced. We have the number that is between 1 to 50. And in the next step, we once again take the middle number of this sequence, that is 25, and check. Now the information that 25 is greater than the number to guess is again important, because we are able to cut our range in half from 1 till 25. And we keep on doing this, and once we reach to the bottom, we would be able to tell that 23 is going to be that number. Now the average number of turns that we take over here is 4, and it is quite low compared to that we had previously, 50 and 100. Let's apply this technique to the pocket tanks game as well. Now this is just a video excerpt that I have taken from the video. I'll just wait for it to start from the beginning. Now the red tank over here is the AI tank, and for the first two shots, it's going to decide the range. First, it's going to throw a missile that is farther from the robot, the maximum it can throw, and the second shot is going to be the minimum it can throw. Now let's see. Now this first shot that it took was the maximum range it can throw to. Now the next shot that it will take will be the minimum ranged shot. This one. Now it's going to iterate over. Now it's going to use the binary search technique to find the range that is actually going to help it reach the other missile, other tank. So that's how binary search is working over here. Now this is also just a pseudo code of binary search. It's just a simplified way to know for reference, so that it can help us code the binary search when we are going to implement it. Just for reference, I've placed it over here, not much significance as such. Okay, so now it's time for the demo. If you have any questions before that regarding the binary search and the search methods in AI, then you can ask. So let's move on to the demo. Now, I'm not going to install Python in this session, as there are various different tutorials and YouTube videos out there that tell us how to install Python. I'm just going to use an online service that is called Google Collab. And Google Collab allows us to run Python code online. It's actually made for research applications in deep learning and so on, but we are going to use it for our tasks, since AI is also a kind of research. So the website that we want to go to is collab.research.google.com. I have placed it over here as well, so you can have a look at the slides when you are searching for it. Then it's going to open this web page that we have. And over here, it's going to ask which notebook that we want to open. Since you would be new to this platform, you would need to select this new notebook. I'm going to select this binary search since I have already coded what I have to show in this session. So I'll open this. You would need to select the new notebook button. Now, Google Colab provides us to write Python code in a notebook kind of format, as we will see over here. A notebook is simply a collection of code text. As we can see, we have this heading text over there and some code that we have written for Python over here. So it's just, notebook is just a collection of Python and code and text. I'll just zoom in so it's more visible. Okay, so when we want to add a new code-based cell over here, then we need to press this plus code button. And if we want to add a text cell, then to press this text button. I'll just press it once. So like it's going to add a new cell, and here we can write the Python code that we're going to write. The delete button is over here. And for the text, we also click the text button and we can then type any text that we have. Something like this. Okay, so once you open this new notebook, then you can change its name from over here. I have written binary search. By default, it will be naming it Untitled. You can change the name. Do not change the extension over here, since we need this extension IPyNB. Okay. Now, the first thing that have to do is to print something on the screen. Now, why we want to do that is when we are playing our guess our number game, then we need to tell the instructions to the user that we have. So what he has to do and so on. For that, we need something to be printed on the screen to tell the user what to do. For that, we have this print command over here. It simply goes like this: print and then the brackets, and inside this we can write anything that we want. If we want to write text or string over here, then we need to add these double quotations that we see, and inside that we can add any text that we want. For instance, sample text 1 2 3, we can add everything over here. I have written hello world since it's the basic thing that we have to do. Now to run this code over here, we can press this button that we see, this play kind of button, or on our keyboard we press shift plus enter. I'm going to use that since that is a more better way or shortcut kind of way. So for first cell, it's going to take some time as it is going to allocate a server in over there, and once it is connected to the server, then it's automatically going to run the code that we are running over here. So it says connected over here, and now in a few moments it will run this code also. So it's running this. Okay, now we can print a lot of different things over here. Like the first example is the text that we saw. Another way to print text or string is to use single quotation marks. Both of these roughly mean the same thing, so we can use either of them. If we want to print numbers, then it is also possible. We can type any number over here. Let's just change it. Let's say we want to print 3. And if we want to also do some mathematical calculations inside the string or text that we have, then the command is something like this: print f, then we write the text that we want, and in these angular brackets we can write any mathematical operation that we want. Let's say I want to write 1 plus 5. So let's run this, and then it says hello world is printed, 3 is also printed, hello world 6 also printed, 1 plus 5 is 6, and print hello world again, quotation marks as well. So printing is done in this way. We just need to use this print command or print function. Variables are simply memory. They are going to store what values that we have. For our applications that we have, we are going to store the lower range, like the one that we had, and for the upper range, we are going to store the 100 that we have. So we are going to use variables for that kind of thing. Now over here, I have declared some variables, and the syntax to do this is just type a name. It should be an alphanumeric kind of thing and should not start with a number. It can even be x123 equals something. It can also be x underscore 1, something like that, and x underscore alpha equals something like that. So it can be any name you would like to type. It should not start with a number. That is a condition. Okay, so we have declared some variables: x equals 1, y equals 2. Now, these variables can store a lot of different things. For our case, we only need to learn that they can store numbers as well as text that we just discussed before. So we are storing x equals 1, y equals 2, s equals hello, and t equals world. So we're going to run this. And there is not going to be any output since this is only a saving kind of operation and there is nothing that is going on over here. To output, we can type these variables in the print over here. So if we want to print what is the value of x, then we type print x. If we want to know what is the value of y, then we type print y, print s, so on. And if we want to do some mathematics, we can also do that by typing x plus y. So it's going to add and return the result that we have. If we want, we can also do some form of mathematics for the strings as well, like the add operation. What it's going to do is simply add both the text that we have, hello plus world, and it's going to print hello world. Another additional thing that you can do, remember the f function that we did over here to do some mathematics in the main string. Let's say that we want to print hello, and we also want to print the value that we have stored in x. So we can do that as well. Now let's also make it a little bit more complex, that we add x plus y, and let's see what the results are for this. So the above things are printed as default things. And over here in the second last, we have printed hello 1 and x has had the value 1. So it's printed here. And x plus y is printed as 3 as we can see over here. So these are what variables do. They store the different values which we can use later on in our that we have. Okay, the next thing that we have to discuss is conditions. Now, why do we need conditions? In the binary search algorithm that we discussed, we need to compare if the number that is given is it less than or equal to or even greater than the number that we have. To do that kind of operation, we need conditions, or we need what are called conditions. Now in Python, we can write these conditions using if, elif, and else kind of statements. So we are first declaring two variables, x equals 1, y equals 2. And it's pretty basic, like we write in English, that if x is less than y, then do something. Else if x is equal to y. Now to compare two things that are equal to each other, we use this notation, x equal y. Single equal does not work. We use x equal y, then do something. And else if all the above conditions are not met, then finally what we should do is written in the else one. So we have this print, do this and that. Now we have this x equals 1 and y equals 2. Now let's run this code and see what is the output over here. Now we know x is 1 and y is 2. X is less than y. Therefore, it's going to run the first print output, that is x equals 1 is less than y equals 2. Now, one thing that you would note is that after this colon that we see over here, there is something that we have applied. Now, in Python, this spacing is important as it tells that the code that we have written down over here comes under the if part. If we want to add something else over here as well, then we can also add it over here. So if we write print1, then it's also going to do this command over here. Now let's change the values of x and y. Let's say x equals 2 and y equals 2. Then let's see what is going to happen. Now then it's going to run the else if statement that we have, x equal y, and it's going to print x equals 2 is equal to y equal 2. If we have x equals 3 and equals 2, then the else statement is going to run, which is x equals 3 greater than y equals 2. Now if we have some more conditions also, then we can also add them over here in elif ones, like elif x equal 2, then do something, and then we can also have elif y equal 2, then do something, and so on. So we can add all the conditions in the else if. The first condition needs to be if, the rest ones need to be else if, and the last condition, if anything does not match, then it needs to go under the else statement. So that's the complete syntax for this Python. Now, else if is also optional. We can completely remove this and our code would also work. So if x is less than y, then do this. If x is not less than y, then do this. So this would mean that. Okay. Now the next thing that we need to discuss are loops. Now in the algorithm, that binary search algorithm that we discussed, we were iterating over the steps. The first step was to cut the range between 1 to 50, then to cut the range between 1 to 25, and then so on. Now, if we don't know the number to guess, then these number of steps are unknown to us. We cannot decide beforehand how many steps are going to be there to write all the code for it. For that, we actually need to use loop. So what is a loop? It's simply to automate repetition. Let's say that I want to print all these lines, that value of x is 0, value of x is 1, value of x is 2, and value of x is 3, and value of x is 4. Now in a very basic way, I would need to write all these one by one. And if we run this, then we can see that is the output we are getting. But to remove the redundancy that we need to type this each and every time, we are using a loop. In Python, we can say that we have two kinds of loops. We are only going to discuss one over here, which is called the while loop. So the first step is that we declare x equals 0 and y equals 5. And the loop goes something like this: while x is less than y, print this. Now let's remove this code over here. Now in basic English, this would mean like till x is less than y, then it's going to keep on printing this. But can see that the value of x is not changing. X is 0 and it will remain 0 throughout, and it will always be less than y. Hence, this loop is going to run indefinitely because the value of x is not changing. Now, to change the value of x, let's write x equals x plus 1 over here. This means to increase the value of x by 1. Now, what is going to happen in this loop? When we enter this loop, x is equal to 0, y equals 5. And after printing this, then x is going to increment its value by 1. So in the next iteration of this loop, we are going to have the value of x as 1, which is going to be printed over here. And in the next iteration, the x is going to increase by 2, 3, 4, and so on. When the value of x reaches 5, then this condition is not going to be met, that we can see over here, and this loop is going to stop. So that is what's going to happen. Let's say that we want to print the x 6 times. So we're going to change y equals 6 and now run this code. So we can see that they have printed x equals 0, 1, 2, 3, 4 till 5. And 6 is not printed because after that the loop was stopped. So these are all the basics that we're going to use for to build the guess the number challenge that we had. We're going to write two operations, which are computer as the host and computer as the player. So if you have any questions before that, you can ask. Okay, so let's move on. Now, the first thing that we want to write is computer as the host. So what this means is that the computer knows what is the number to guess, and we are going to tell the computer, ask the computer, is it the number that it is? So now this sounds like kind of cheating, but we are also the ones who are creating this, and we are also the ones who are playing it. So the number that we want to guess, we are going to store this in a variable called number to guess. And as discussed, we are taking that number as 23. Then we declare another variable guessed number that is equal to -1. This is initialized by -1. We are going to change it later. What this variable is going to store is the number that we are telling the computer, asking the computer if it's the number or not. That's why the name guessed number. So the first thing that we're going to do is print welcome to guess the number game. This is simply an instruction that we are telling to the user. And then we have this loop while guessed number is not equal to guess. What this means, this loop is going to run till the guessed number is equal to the number to guess. Once the value of this guessed number is equal to 23, this loop is going to stop. And once this loop stops, then we are going to print correct, your guessed number is the number to guess. Now let's see what is going on inside this while loop as well. So first we give an instruction to the user that type your guess. And we have a variable guessed number. And the operation that we see over here, int input, this is simply to take an integer value from the user. Input is to take value to take keyboard values, and int is simply converting it to an integer like 23, 1, and so on, the number that we type. And now we have some conditions over here. If guessed number is less than number to guess, then we tell the user that your guessed number is less than the number to guess. And else if the guessed number is greater than the number to guess, then your guessed number is greater than the number to guess. If none of these, if the guessed number is equal to number to guess, then none of these two conditions is going to work. And in the next iteration, the while loop is going to stop and give us this print command output. So let's run this game and see how this works. We are going to use the binary search technique as we have been using. Okay. So it's asks what type your guess. So I'm going to type the guess as 50. And it says your guess number 50 is greater than the number guess. And that is correct because 50 and 23. Now let's say I'll just deviate from the process that we have. Let's say that I type the number 20. Now it says that your guess number 20 is less than the number to guess. That is also correct because 20 is less than 23. Now let's type in 23, and finally the complete code stops and says correct, your guess number 23 is the number to guess. So that way the computer is going to play the whole game with us. And in this case, the computer is the host that is playing the game. This is not this is not AI, because it is just coding everything and asking us the things. The AI that we are doing is us. Now we need to reverse the roles and see how we are going to apply AI as the computer. So the first step that we do is declare a variable called lower range, which is equal to 1, as we have, and we declare a variable upper range that is equal to 100. And the status variable over here that is going to store some form of text. Now what status is going to save is the number equal, is the number less, or is the number more. So in this case, the computer is going to ask us, is it the number to guess? And we are required to tell the computer if the number is less, equal, or greater than the number that is there. So as a user, we can only type in 3 words in when the computer asks equal, less, or more. So this loop that we have over here, while status is not equal to equal, this is going to run till the value of status is equal to equal. Now to the way to check if the two things are not equal to each other is exclamation equal in Python. Once this loop has completed and once the status variable takes on the value equal, then we are going to print great. So the number to guess was whatever the guess that had. Okay, so inside the loop, we have this guess variable that we have int equal lower range plus upper range divided by 2. This is the same, the middle value in the range that we are taking. Now, after dividing by 2, we can see like even in the first case, if we do lower range plus upper range divided by 2, then it's going to be 101 divided by 2. And it's going to give us a fractional kind of number. And we don't really want that because we are not considering fractions over here. To just round it up, we use this integer operation over here so that it rounds the number. So now then, after this, the computer asks us, is the number whatever the middle value that it found? And then it takes this input from us, which we are going to type, is it less, more, or greater? Now, then we have some conditions over here that if status, if we type in that the number is less, then it's going to set the upper range is equal to guess minus 1. And if we type the status as more, then it's going to take in the lower range as guess plus 1. Let's consider an example for this. Let's say that the range currently is 1 to 100. And after that, the computer says is the number 50. So if the computer says that the number is 50 and the number to guess was 23, now that is going to reduce the range to half. This means that the computer needs to have the range from 1 to 49. Why 9? Because 23 is less than 50. So now the current range that we have is 1 to 49. And this is what we are doing over here. We are reducing the upper range to guess minus 1. Let's say that we said 50 and the number to guess was 75. This means that now the range is going to change to 51 till 100. This is also implemented over here that the lower range is equal to guess plus 1, which is 50 plus 1. So these are the things that are happening over here. Now let's run this code to see how it works. So the first question that it asks is the number 50. So we are going to use 23 as our reference as we had. So is the number 50? So number is not 50, 23 is less than 50. So we ask is the number 25? So the number 23 is less than 25. 23 is greater than 12. It's again greater than 18 and it's greater than 21 and is the number 23 and we type equal. So great, the computer has guessed that the number was 23. So this way the computer is working and this is what we can say form of AI that is guessing the number that we have in our mind given the range that we have. Okay, so this is all related to the demo now. Let's just move on to the end. Okay. All right, so all the demo is done. And what I would like to So the session is also more or less over. This is all that I had to discuss for this session. Now, what I would like you to do is you would, if you would like, you can replicate the instructions that I have told you in this video, and you can post it on social media with the different screenshots and all the things that you have just coded over here. You can be as creative as you want, and you can share these on Twitter or LinkedIn while tagging me, so I can also have a look at what have you done. uh, it's completely optional. If you want to do it, would be great if you do it. It's a great portfolio building and exercise that you would like to do. It just builds your portfolio so you can show to people what you have learned and so on. And remember to tag me. I am available on these two social media platforms, Twitter and LinkedIn. And yeah, so this is all that I had to discuss. If there are any questions, you can ask. Otherwise, we are done. And thank you all for attending. It was very nice to take the session.